Okay, in this next example, we're still going to draw two cards from a standard deck of 52 playing cards with replacement. So that's a key part right there, with replacement. That means the denominator stays the same. Also, the question is probability of a king and an ace. Okay, so in this case, we can have multiple scenarios. That means we can draw a king followed by an ace, or we can draw an ace followed by a king, and it satisfies this question, king and ace. There's no specific order listed there. So in this situation, what we do is we find the probability of a king, then an ace in that specific order. We also find the probability of an ace, then a king in that specific order. And since those are the two scenarios, we add those two fractions together. Now, in my previous videos, we definitely indicated that the word or indicates addition and the word and indicates multiplication. So you need to be really careful here. The word and here is telling you that you can draw a king and an ace in either order. That's the piece right there. And if you notice down here where it says add the fractions together, so adding usually indicates that we have an or. Okay, so even though there's not an or in this question, in the scenarios created by this question, there is an or, and it's right here. It can be king, ace, or ace, king. So for those of you who try to find, shortcuts or specific words to get you through the process, just be really careful in this situation, because the word and will sometimes indicate that you need to multiply, and that's true. However, this language in this question right here indicates you're going to have a king, ace, or an ace, king, and this is the or that indicates the addition down here. So to start this question, we need to identify the probabilities of a king followed by an ace with replacement, and then we need to find the probabilities of an ace followed by a king. So in the standard deck, you can see that there are 4 kings out of a total of 52 cards. So for this calculation here, the probability of a king and then the ace is the same type of calculation we did in the previous slide. So that would be 4 kings out of 52 cards in the deck times the probability of an ace, which would be 4 aces out of 52 cards in the deck. Again, it makes your life a little easier when you simplify these fractions. So they both simplify to 1/13, and then we multiply the two of those together and get an overall probability of 1/169. Next, we have to find the probabilities of an ace followed by a king. Okay, same format as the previous example. So there are 4 aces in the deck out of 52 cards. We're going to multiply that to the probability of a king followed by a king, so that's 4 kings out of 52 cards. Both of these fractions, again, simplify to 1/13. And when we take the product of both of those, we also get 1/169 here. Now, to find the overall calculation of the probability of a king and an ace, we're now going to multiply these two probabilities together. So the reason we're adding these fractions is because to find the probability of a king and an ace, that gives us a scenario where it's the probability of a king, then an ace, or the probability of an ace, then a king. The key word or here is our indication that we're adding. So in our scenario, probability of king then ace is 1/169th, plus probability of an ace then king is 1/169th, and we add those two values together, we have 2 out of 1/169th, excuse me. Again, simplified fraction, no percentages.